Okay, can you read the slides? Is it visible?
Yes, ma'am.
Okay, so let's start. So today's topic is on network layer routing algorithm. So in the last class, uh, we have studied static routing, and in today's class, we will start dynamic routing. So basically, routing are two types. Number one is static, and the second one is dynamic routing. So in static routing, network administrator manually writes every command in the router to reach the destination from the source. But in dynamic routing, what happens? The network administrator does not write anything manually. Rather, routing algorithms are installed inside the routers, and router computes shortest path based on those routing algorithm using two types of techniques. So these two types of techniques will be covered in the next two class. So today we will cover distance vector routing, and on the next class we will study link state routing. So what's the principle behind this routing algorithm? We will cover now shortly. The first one is there are many popular routing protocols which are used nowadays, but basically routing protocols are divided into two types. One is intra-domain routing and another one is inter-domain routing. So basically in our lecture we will cover only the inter-domain part, but inter-domain is skipped from our syllabus. So today we will study distance vector, and in lab 5 you will do the RIP version 2 algorithm in the packet tracer. So you will have an idea how to configure this algorithm when you are configuring a network. So let's start the theory part. So in inter-domain routing, what happens is first you have to know about idea of an autonomous system. So what is an autonomous system? If this is the internet, which are connected with many routers and many networks together, autonomous system is basically a network topology where there could be many LANs, many WANs connected with each other, but on those topology, the total area is under one administration router. So here there are three clouds uh, showing in the diagram. So the first autonomous system ASA means this cloud area where there are 1, 2, 3, 4, 5, 6 routers. All are connected with each other either directly or indirectly. But this autonomous system means these routers is under administration of one router. It could be this router or any other router in the system, but basically under one router all other networks are administrated. So if I communicate within the autonomous system, suppose from this network to this network, that is called intra-domain routing, okay, within the autonomous system. And if I communicate from one autonomous system to another, suppose autonomous system C to autonomous system A, suppose from this network to this network, so that is called inter-domain routing. So basically uh, we will cover only the intra-domain part, and thus this line, the heavy lines are indicated to denote the inter-domain connections, and these lighter lines indicating there is inter-domain connection between the routers. So basically we will cover the routing under one autonomous system which is called intra-domain routing. Okay, so an autonomous system is a group of networks and router under the authority of a single administration or single router. So this is the important part. So we will cover only the routing inside an autonomous system, which is called intra-domain routing. So for intra-domain routing, we will cover two types of routing algorithm. One is distance vector routing and another one is linked state routing. Both type of routing algorithms have some advantages and disadvantages. So we will look into the details one after another. So basically what a routing algorithm does, it actually computes the shortest path from the source to destination. And shortest path means the good path from source to destination. The path which have a least cost, we indicate is as a good path. There are two types of classification of this routing algorithm. One is global and another one is local. Global means in the autonomous system, all the routers have the complete information of the topology. That means every router in one autonomous system, that means inside one intra-domain, they have the knowledge of the whole network or whole topology. That idea is used in linked state algorithm. And another thing which is called local or decentralized approach, where every router does not have the information of the whole topology. Basically, it depends on its neighbor to know or to learn about the other networks. So they actually totally depends on the physically connected neighbors to know about the information about the topology. So we will learn this topology in today's class, that is called distance vector algorithm, and how this distance vector algorithm computes the shortest path in a topology. We will look into it. So let's start. So you have studied, I think, Bellman-Ford algorithm in CSE 221. So this algorithm is basically used to compute the shortest path while using the distance vector routing algorithm. So we all know how the algorithm works, so I'm not going into that part. So I'll just focus on how the routers behave when the routing algorithm is started inside a router. So the shortest path basically is the cost calculated from the source node to destination node. And to calculate the shortest path, you have to depend on your directly connected neighbors. And the cost basically arbitrary. You can make any metric to compute the cost. In this class, we will use hop count as the metric. In some algorithm, they use link delay or bandwidth also for cost calculation, but in today's class, we will only focus on hop count. Okay. So the basic idea is, as distance vector routing algorithm, each router depends totally on its neighbor to learn about the topology. So each node periodically sends its distance vector to its neighbor. The time is 30 seconds. After 30 seconds, I share my information with my directly connected neighbors. And when I receive, or any node or router receives this new distance vector, it estimates the cost for itself. And then it updates its routing table using the Bellman-Ford equation. So let's check how these things are done. So in the operation of distance vector routing, which I have already said, it uses periodic updates. That means it periodically broadcasts, a router periodically broadcasts its entire routing table to each of its neighbor. So in our case, it will be 30 seconds. So if you have something to, update or not, you are continuously actually sending a broadcast message to your neighbor. So sometimes this is inefficient because repetitive information may be broadcast all the time. So in that case, or in such cases, periodic updates are not efficient. And remember, while using distance vector routing algorithm, router only aware of its own information and directly connected neighbors information. Router do not have the whole knowledge of the topology. So that's the main thing of distance vector algorithm. So let's look into this topology. Suppose in this intra domain there are four routers connected with each other, and at the very beginning, uh, each router first sends periodic updates to its directly connected neighbors. So R1 makes its routing table information. At the very beginning, it has no other information, only it have the information of its directly connected interfaces information. So this is the information which is used at the very beginning. So this information will be shared with router R2 and R4 only. Router R3 is not going to get this information because R3 is not connected with R1. So that's very important. Okay. So as the neighbors are R2 and R4, they have received the information, and at this moment R1 doesn't know anything about R3 because R3 is not connected with R1. So if there is any router here or on the other side, router R1 is not aware of it at the very beginning because it is not directly connected. So the first phase is called the network discovery phase, where I send the packets to my directly connected neighbors, and if I receive the information from the other side, uh, then I can be sure that yes, on the other side I have also another router and he is sending me also a periodic updates. So let's start how these things are working. Okay, so in this topology, R1, R2 and R3 are connected routers, but R1 is only connected with R2 and R2 is connected with R1 and R3, and R3 is only connected with R2. So basically at the very beginning, we called it cold start phase, the network discovery phase. The discovery phase is basically when the router is just power up, you just on the devices. So it knows nothing about the network topology. So as there is nothing information shared with its neighbor, so it has no information of the topology. That's why it is called cold start. So if a router only have the information of its own, so that means what is saved in its RAM, it is going to use that information at the very beginning, and it is going to send these updates to its directly connected link. So at first, when router 1 is powered on, in its routing table, how many information can be stored or can be seen? Only one information, that is connected with this router R1. So which network is connected with router R1? This part and this part, right? So on the left side there is a fast Ethernet port connected with router R1, and this network address is 10.1.0.0, and this is the interface number, and the number of hop is 0. That means R1 is connected with 10.1.0 network in fast Ethernet 00 interface, and to reach this network, how many hops router R1 has to cross? 0 hops, because it is directly connected. And also on the right side, on hand number is 000, the network address is this, and the hop count is 0. So at the very beginning, router R1 only knows its own information, the two network which is connected with router R1. Same goes for router R2 and router R3. If you write for router R2, so router R2 has these two information, two networks connected with serial 00 and serial 01 hand, and hop count is 0. And for R3, one is fast Ethernet 00 connection and another one is serial connection. So this is the basic information at the very beginning, or network discovery or cold start phase. So when I have powered on my devices, router have this much information within itself, and now this information is called the routing table. Okay, so this routing table is now going to be shared with the directly connected neighbors. So router R1 will broadcast this routing table information in its both hands. So there is one hand on the left side and another hand on the right side. So this routing table will be shared on the both side, right? So if this information is shared, if you look into the left side, there will be no reply coming from the left side because there is no router connected with fast ethernet hands. Okay, so it's a LAN, end of the LAN. So there will be some end devices like PC or servers, so they are not going to send any routing information to router R1 because they are not routers. So routers only shares the routing table. So that's why from left side, this way no information about routing is going to come to router R1. So that's why this interface is called passive interface. So if you send any routing information on the left side of router R1, no information will come back to router R1. That's why it is called passive interface. But on the other hand, if you send your routing table using A00 hands, there will be a response from router R2 using A00 hands because router R1 has a connected router on the right side. Okay, so this A00 hand is passive interface. So remember these two parts, it will be also needed on the lab. So this is the passive interface, active interface, and this side is the passive interface. So active interface means from which you get a reply from another router. Okay, can you hear me? Hello.
Yes, ma'am.
ওকে, if you
Yes, ma'am.
having any problem please ask me, okay? কারণ অনেকক্ষণ ধরে কেউ কোনো রেসপন্স দিচ্ছ না, so please ask me if you don't understand.
Okay, ma'am.
So router R1 is going to share its routing table with the both hands. So from the left hand there is no response, and from the right hand there will be a response. So for router R2, it is also going to share its routing table, this routing table. So router R2 is going to share its routing table with R1 router and R3 router because both are connected with R2, directly connected. And R3 is going to share its routing table with R2 only. Okay. So after this exchange of initial routing table, what happens? R1 knows information of router R2. So basically now after 30 seconds, when another router give me the routing table of it, I can make my own routing table based on that information. So after receiving routing table from R2, R1 is going to make its new routing table. So basically this routing table was the first phase. Now after receiving routing table from R2, R1 can make other entries depending on this value. So what information R2 is sharing with R1 right now? Can anybody tell me? What information R2 is sharing with R1 right now? কেউ বলতে পারবা না? Nobody?
Ma'am, the interface address.
No, R2 is sharing its routing table. That means this table. Okay, this table is shared with directly connected routers. So if this R2 routing table is shared with router R1, what new information router R1 have from R2? কেউ চাইলে বাংলায়ও বলতে পারো। আচ্ছা, আমি বাংলায় কোশ্চেনটা করি। R2 থেকে রাউটিং টেবিলটা যদি R1 পায় এখন, তাহলে R1 এর কাছে নতুন কি ইনফরমেশন আসবে যেটা R2 থেকে সে পাচ্ছে?
Ma'am, কিছু নেটওয়ার্ক অ্যাড্রেস, কিছু ইন্টারফেস অ্যাড্রেস এগুলো।
সো কিছু নেটওয়ার্ক অ্যাড্রেস পাচ্ছে, রাইট? সো এই যে নেটওয়ার্ক অ্যাড্রেসটা রাউটার R1 is receiving from R2, is it new or is it already known by router R1?
Already know. The only unknown is 10.3.0. So to know that
10.0.0 is already known because it's in this network router R1 is also there. So this is not a new information for router R1. So it will not be entered here because it is already there. but a new information pops up about 10.3.0.0 network, which is this one. So this network was not known to R1. Right now, it has received this information from R2. So this information will be added in router R1's routing table. So it enters 10.3.0.0, and from which interface it has learned this network. See, 10.3.0.0, this network is connected with router S001 interface, but here the interface information is S000. That means this information is received by this interface of router R1. That's why this is written S000. So this interface is not the interface of router R2. This interface is the interface of router R1. So remember this is a very important thing. So router R1 learn the network address or network information of 10.3.0.0 from router R2, and as it receives this information using this interface, so this interface address is written. And how many hops router R1 have to cross to reach this? Only one, right? Only router R2. If you cross router R2, you can reach here. So the hop count increased by 1. Did you get my point? Okay. So for router R2, if it receives information both from R1 and R3, because they are both connected routers with R2, what will be the new entry of the routing table of R2? Any new
Ma'am, the
information?
first network address of router 1,
Yes. What is
and
the address?
ma'am, 10.1.0.0.
Right, 10.1.0.0.
And the second address, second network address of the router 3, which
Right,
is 10.4.0.0.
very good. And what will be the interfaces information? Can you guess?
In both cases, router two's interface is receiving the address, so the interfaces of both side of router 2 will be added in the table,
So
which
for
is S0.
10.1.0.0, which interface will be written?
It will be S0/0/0.
Okay, very good. Okay, so
And
this information is added.
yes, ma'am. And for router two's address, it will be S0/0/1.
Okay, right. Again, for router 3, who is going to send the information to router 3? Only router 2. Router R1 doesn't know R3, that's why the routing table of R1 will not be shared. Okay, so router R3, if just look here. Okay, so this is the first phase. So at this moment, this routing table is shared with this router, and this routing table is shared with this router and this router, and this routing table is shared with this router. So if I make the routing table of R3, how many information will be added on the first step?
Two information.
Two information? Are you sure? R3 will receive information from R1.
Oh, sorry, ma'am. One information.
Information, right? Very good. So that's the first step. So each time after 30 seconds, each routing table is exchanged. So you have to make the same time routing table exchange with each other. So the first routing table with router R2, the first routing table of R1 and R3 with R2, and the first routing table of R2 with R3, right? So
Ma'am, can you repeat the step once more, please?
আবার বলবো?
Yes, ma'am.
আচ্ছা, প্রথমে আরেকটু বাংলায় বলে নিই, তারপরে ইংরেজিতে বলতেছি। তো
Sure, ma'am.
সবার প্রথমে যে জিনিসটা হবে সেটা হচ্ছে প্রত্যেকটা রাউটারের একটা ইনিশিয়াল রাউটিং টেবিল আছে, সেটা হচ্ছে এটা, রাইট? এটা হচ্ছে 0 সেকেন্ডের টেবিল, এটা হচ্ছে 0 সেকেন্ডের টেবিল, এটা হচ্ছে 0 সেকেন্ডের টেবিল, রাইট? এখন 0 সেকেন্ড ক্রস হওয়ার পরে আমি নেক্সট টেবিলটা তৈরি করব হচ্ছে 30 সেকেন্ডের সময়। তো 0 থেকে 29 সেকেন্ডের মধ্যে R1 কোন ইনফরমেশনটা পাবে? R2 এর 0 সেকেন্ডের টেবিলটা, তাই না? R2 এর 0 সেকেন্ডের টেবিলটা ইউজ করে R1 কি করবে? সেকেন্ড রাউটিং টেবিলটা বানাবে, রাইট? আমার কথা কি বোঝা গেছে?
ইয়েস ম্যাম।
R1 এর একটা 0 সেকেন্ডের টেবিল আছে, যেটা হচ্ছে এটা। এখন R1 যদি তার 30 সেকেন্ডের টেবিলটা বানাতে চায়, দ্যাট মিনস সেকেন্ড টেবিলটা বানাতে চায়, তখন সেকেন্ড টেবিলটা যে বানাবে কোন ইনফরমেশনের উপর বেস করে?
R2 এর আন্ডারে যে টেবিলটা আছে এটার
R2 এর 0তম সেকেন্ডের যে টেবিলটা আছে সেটা, মানে R2 এর ইনিশিয়াল টেবিলটা। R2 এর ইনিশিয়াল টেবিলে কি ছিল? 2 আর 3 এর ইনফরমেশন ছিল। তাহলে এখানে 3 এর ইনফরমেশনটা অ্যাড হবে। 3 এর ইনফরমেশনটা অ্যাড হওয়ার পরে যে টেবিলটা আমি পাইলাম ওটাকে আমি বলবো সেকেন্ডের টেবিল বা সেকেন্ড টেবিল। বুঝা গেছে? সেকেন্ড টেবিল অফ রাউটার R1। সেম থিং গোজ ফর R2। R2 যখন তার 0 সেকেন্ডের টেবিলকে নিয়ে বসে আছে এটা, তখন বাকি দুইজনের, দ্যাট মিনস R1 এবং R3 এর 0 সেকেন্ডের টেবিল নিয়ে সে কি করবে? রিসিভ করবে। তারপরে R2 হচ্ছে 1 এবং 3 এর 0 সেকেন্ডের টেবিলের ইনফরমেশন নিয়ে 30তম সেকেন্ডের টেবিলটা বানাবে, দ্যাট ইজ সেকেন্ড টেবিল। বোঝা গেছে? ক্লিয়ার?
ইয়েস ম্যাম। ম্যাম ফার্স্টে হচ্ছে R1 হচ্ছে R টেবিল নিয়ে টেবিল বানাবে,
হ্যাঁ,
তারপর R2 R1 এর থেকে নিবে আর R3 থেকে নিবে, ও
রাইট,
দুই সাইড থেকে নিয়ে R2 বানাবে।
নিয়ে বানাবে। ফর R3, হু ইজ গোয়িং টু সেন্ড দ্য টেবিল ফর R3? অনলি R2, তাই না? R2
Yes,
এর R2 এর 0তম সেকেন্ডের টেবিলে কি দেওয়া আছে? R2 এর 0তম সেকেন্ডের টেবিলে কি দেওয়া আছে? এই দুটো ইনফরমেশন না?
yes,
So these two information of R2 is going to be shared with R3, and then R3 is going to make it second routing table. So second routing table কোন ইনফরমেশনটা নতুন হয়ে অ্যাড হবে? 10.2.0.0, তারপরে S0/0/1 hop count 1। বোঝা গেছে? ওকে
okay.
ওকে। So at the very first step, router R1 is going to receive the table from R2, and then it will going to make the second table for itself. Same case goes for R2. It will receive the initial table from R1 and R3 and make its new table, and R3 is going to receive the old table or zeroth table of R2, and it will make the new table for the next update. So in the second step, when router R2 receives information from R1 and R3, it already knows all the network addresses of the topology because it is in the middle, so it receives information from the both routers. But still, the two routers R1 and R3 did not have the whole knowledge, right? So
Yes.
at the third step, when again 0th table or the first table is this one. First table is this one. I can call it as first table or initial table, whatever you say. And this is the second table. This is the second table. Second table and second table. So router 2 is already updated at the second phase because it has all the information of the topology, but R1 and R3 is not yet. So at the third step, when router R2 again share its routing information with R1 and R3, that moment R1 will know about the network connected with router R3. So next step, when router R1 shares its routing table with R2, it has nothing new in its routing table, so R2's routing table will not update. But R2 has something new information to share with R1 because it has the network information of R3. So if now R2 share its information with R1, it has a new information of the phone network which will be new for router R1. So it will be added on the routing table of R1 with hop count of 2, right? And using this interface, it has learned this information, so interface is S000. So same case goes for router R3. So after receiving the updated table from R2, R3 will know about the network address of this, and it will be added to this entry, and the hop count will be 2. বোঝা গেছে?
ম্যাম নেটওয়ার্কের পার্টটা বুঝে গেছে ম্যাম, হপ কাউন্টের বিষয়টা ম্যাম আরেকটা
হপ কাউন্টার, আচ্ছা। সো এখানে দেখো, সো when router R2 is sharing its routing table with R1, what new information router R2 have? This one is old, this one is old, this one is old, right? But this information is new for R1, right? For R2,
ইয়েস
if you want to reach network number 4, how many hop you have to pass? From R2, if you want to reach network 4, how many hop you have to pass? 1, right?
ওয়ান
Right. This information is now shared with router R1. So from router R1 perspective, how many hop router R1 has to pass if it want to reach network number 4?
টু হপস
2 hops, you can see it's 2 hops. I can see, like, if there is pictorial representation, but for R1 there is no pictorial representation. So how R1 is going to calculate it? R1 is going to calculate it from the routing table. For R2 it is 1, and from R1 to R2 how many hops do you have to cross? 1, right? So you just add 1
অ্যাড
plus 1, 2. বোঝা গেছে?
ইয়েস ম্যাম
So that's how you can make the hop count and make entry in the routing table. So using this exchange of information, what we can say at the very beginning, initial routing table, which network information can I see in my routing table? At the very beginning, when the routers are just powered on, which information is visible in the routing table of the router? Which information?
Networks that the routers are directly connected with.
The networks or interfaces which is directly connected with that router, right? Okay. After the first update, which information is added in the router's routing table? The network,
Networks that are one hop away.
which is only 1 hop away. That is, from here, 1 hop, this network, 1 hop away. At the second update, what I can say, which networks are entered in the routing table? The networks which is 2 hop away, right? বোঝা গেছে? So if there are other networks, routers connected more remotely, after each update, 1 will be added. So if you are very far from a router, it depends on how many hops you are far. বোঝা গেছে? Clear?
ইয়েস
Yes, please.
Any question? So these things are important. Initial routing table, after first update, how many information can be added in a router? After second update, you have the information of the network which is within 2 hops. After the third update, the information of a network which is 3 hop away will be added to your routing table. Okay? বোঝা গেছে? Any question? Okay. So using this distance vector routing algorithm, what can be said now? How long does a router will take to actually make your routing table, I mean, converged or stable? if the network size is too big, will it be a good or bad if I use distance vector routing table or distance vector routing algorithm?
Bad because it's a very much.
Because if you have many routers connected and some are very much, 10 12 hops away, it will take more time for a router to know about the topology, because router R1 actually totally depends on R2. If R2 says there are network on the other side, router R1 enters that. If router R2 says there is no network, then router R1 will have no idea whether there is any routers or networks there available or not. So in such cases, when you have to believe or you have to rely on your directly connected routers, you may not have get the proper information of the topology, because if router R2 is an attacker router and this router is sending you a false information, you have no way to verify this. So in such cases, distance vector routing algorithm is not good. বুঝা গেছে কি বলছি? Okay, so after each updates, if your routing table does not change, like after this is the initial table, this is the first update and this is the second update, and for the third update, if again router R3 sends this information to R2 and R2 sends this information to R1 and R3, is there going to be any changes in the routing table? Any new information will be added? No, because there is no information left. So at that moment, you can say your network has been converged. That means your network is stable. All the routers have the knowledge of all the networks of your topology. So at that moment, your network is converged and stable. And after that, you can start sending the data or packet from one place to another. Before network convergence, you cannot send any data because all routers don't have all the information. So if you send any data, your packet may be dropped. Okay. So that's how distance vector routing algorithm works. So if your network is like in such a way where many routers are connected, it's a very large network, your speed of convergence will be very slow because it may take some time to propagate the information from here to here, right? So if I am here and this router have to know the information of this router, so how many hops it has to cross, right? Many hops. So it will take more time to make the routing table and it will make more time to make it stable. So that's why for larger network, distance vector routing algorithm is not a good option. Okay, clear? বোঝা গেছে? So that's all for today's class. If you have any question, you can ask me. কারো কোনো question আছে?
No, ma'am.
So it's a very easy topic. এমন কঠিন কিছু না. So there is another one which we will cover after the Eid vacation. So that's all from today's class.
ম্যাম আমাদের ফাইনালের সিলেবাস তো লেকচার স্লাইড 7 থেকে একদম লাস্ট পর্যন্ত।
হ্যাঁ, যা ফাইনালে যা পড়ানো হয়েছে বা পড়ানো হবে সবগুলোই থাকবে, মিড থেকে কিছু থাকবে না।
ম্যাম তাহলে আমার মিডের পর থেকে হচ্ছে নেটওয়ার্ক লেয়ার IPv4 ফাংশনস থেকে শুরু হয়েছে আর কি।
সাবনেটিং থেকে ফাংশনস, তারপর সাবনেটিং। ইয়েস। ওকে, ডু ইউ হ্যাভ এনি কোয়েশ্চেন? আছে? Okay, so just wait a bit, I'll take the attendance, okay?
ম্যাম প্রিভিয়াস ক্লাসে ম্যাম আমি ক্লাসে মোটামুটি রেসপন্সিভ ছিলাম ম্যাম, আমার ল্যাপটপ ম্যাম হঠাৎ করে ফ্রিজ হয়ে গেছিল আর আমি অ্যাটেন্ডেন্স দিতে পারিনি ম্যাম।
আচ্ছা, আমি হয়তো দিয়ে দিছি, তুমি দেখো চেক করে, আমি একটু অ্যাটেন্ডেন্সটা নিচ্ছি, ইউ জাস্ট চেক, ওকে? প্রথম হচ্ছে সেকশন 9, উম্মে মাহবুবা।
Yes, ma'am.
তাশফি আলম, সোমতীর্থ বড়ুয়া, নাফিম আহমেদ, মুতাসিম,
Present, ma'am.
তৌসিফ আবরার, রাহাতুল ইসলাম ফারদিন,
Present, ma'am.
শারফুদ্দিন সিয়াম, মাইমুনা রহমান, রিতিশা ইসলাম, হাসনাইন হাবিব,
Present, ma'am.
Yes, ma'am. Ma'am, Hasnain.
রাফিন রহমান,
Yes, ma'am.
শেফি সরকার,
Present, ma'am.
মির্জা
Present,
মেহরাব,
ma'am.
মির্জা মেহরাব, ইশাদ ফারিহা, রুদাবে তৌফিক,
Present, ma'am.
মুর্শেদ জামিল,
ম্যাম প্রেজেন্ট। ম্যাম আমারটাই ম্যাম কালকে অ্যাবসেন্ট ছিল, আমি দেখতেছি।
আমি দিছি তো দেখো।
স্ক্রিন শেয়ার নাই তো দেখতে পাচ্ছি। ওকে ম্যাম, থ্যাংক ইউ ম্যাম।
আমি দেখাচ্ছি না। এখন দেখা যায়?
ইয়েস ম্যাম, থ্যাংক ইউ ম্যাম।
ওকে, সালাউদ্দিন মাহমুদ, সাইদ ইসমাম, জাহিন আবরার, সার্থক দাস,
Yes, ma'am.
রওশন আরা,
Present, ma'am.
নাসিফ আহমেদ নাফি, কৌশিক দত্ত, কাজী মাহাথির,
Present, ma'am.
ফারদিন পারভেজ,
Present, ma'am.
অরিক হোসেন,
Present, ma'am.
নাজিহা ইসলাম।
তাই নাসিফা বললো যে তার ইন্টারনেটে কিছু সমস্যা হচ্ছে, কারণ
বুঝতে পারি নাই কি বললা।
নাসিফার ইন্টারনেটে সমস্যা হচ্ছে না, এই কারণে হয়তো তো
ওকে, আমি দিয়ে দিছি। ওকে, সেকশন 9 হয়ে গেছে, ইউ ক্যান গো। এখন সেকশন 10। শাহরিয়ার ইসলাম,
Present, ma'am.
নিশাত তাসনিম নোভা, মারাজুল ইসলাম, মাহমুদুর রহমান তুষার,
ma'am.
কুমার ইবতিসাম নিবিড়,
Yes, ma'am.
তানভীর ইসলাম,
Present, ma'am.
সবুজ আহমেদ, সানজিদা তামান্না, লিঙ্কন ধর,
Yes.
মৌরিকা নিগার,
Present, miss.
সৌমিত্র সরকার,
Present, ma'am.
ইসরাতুল হাসান,
Yes, ma'am.
মাহির আহনাফ,
Present, ma'am.
বখতিয়ার রহমান, মালিহা মেহজাবিন,
Present, ma'am.
অরিত্র ঘোষ,
Present, ma'am.
সাইদুর রহমান,
Present, miss.
তাসমিয়া হাসান,
Present, miss.
রিদওয়ান নূর, আমরিন রশিদ, আবরার ফাইয়াজ, কনক রয়, ক্রিশ্চিয়ান,
Present.
হুমায়রা বাসিত,
Present, ma'am.
রাগিব মোহাম্মদ,
Present, miss.
ইবনাত তাসনিম খান,
Present.
তাসনিম আক্তার ফারিহা।
Present, ma'am.
এনিবডি এলস? এমন কেউ আছো অ্যাটেন্ডেন্স দেওয়া হয়নি? ওকে, ওকে, ইউ ক্যান লিভ, থ্যাংক ইউ।
Eid Mubarak, ma'am.
I'll share that recordings at night, okay?